I want you to picture a scenario for a moment, and I don't mean a comfortable one.
Okay.
Imagine you are sitting inside a Stryker combat vehicle. You're in the
Yeah.
middle of a desert. It's 120 degrees outside. Sun is just beating down on the armor.
Oh, yeah.
And you're bouncing over terrain so rough that your teeth are practically rattling out of your skull.
It's the kind of environment where absolutely everything breaks. I mean, mechanical parts, human focus, and especially electronics.
Exactly. And in the middle of all this chaos, you aren't just driving. You are relying on a computer system to tell you if that drone buzzing, say, 500 feet overhead, is a friendly surveillance unit.
Or something much, much worse.
Or a loitering munition about to strike. And you need that answer not in a minute, not in 10 seconds, but literally in milliseconds.
And this is where we run into, I think, the biggest misconception people have about artificial intelligence.
Right.
We're so used to ChatGPT or, whatever tool we use on our laptops that we assume AI is this omnipresent magical force. We just think of the cloud.
Right. The cloud. The answer to everything.
But physically, the cloud is a lie. Or, well, it's the luxury at least. The cloud is a pristine, silent data center somewhere in Northern Virginia or Oregon. It has unlimited power, perfect humidity control, massive air conditioning units, keeping everything at a chill 65 degrees. It's safe.
And that Stryker vehicle in the desert is definitely not safe.
No. It's what I call the fair weather friend problem. Cloud AI is incredible when you have a 5G signal, a stable power grid, and a Starbucks down the street.
Sure.
But in the scenarios you just described, a war zone or an oil rig in a screaming Atlantic storm or an industrial disaster site, the cloud doesn't exist. You cannot wait for a signal to bounce to a server in Virginia and back to make a life or death decision.
Because if the connection drops, or if the latency, that lag time is even half a second too slow,
then the decision is made for you, and usually it's catastrophic.
that is the perfect setup for today's deep dive.
Yeah.
We're exploring the massive, often ignored gap between standard AI, the kind that lives in the air conditioning,
And rugged AI, the kind that has to work when the world is effectively trying to kill the computer.
It's a completely different sport.
It is. It's the difference between a Formula One car and a tank.
And to help us navigate this, we are looking at a company that has positioned itself as the protagonist of this story. A company called One Stop Systems, or OSS, ticker symbol OSS.
Right.
They're a microcap, but looking at the source material, they seem to be making some very loud moves to become the architect of the autonomous battlefield.
They really are. And we're looking at this through the lens of a source titled The Investor's Code, Mastering Rugged Edge AI and OSS. And the timing here is just critical.
Okay, why?
Today is January 20, 2026. If you looked at this company 6 months ago, you would see a very different business. They've just gone through a major divestiture, they've landed a significant new defense win, and they are trying to prove that they are the pure-play leader in this space.
So our mission today is to unpack this. We're going to define the tech. What is the actual difference between edge AI and rugged AI? We're going to look at their burn the ships strategy, their financial fortress, and why physics, specifically heat, is actually their biggest competitive advantage.
Right.
But first, let's start with the basics. You mentioned the cloud is a fair weather friend.
Yeah.
So what is the alternative?
The alternative is moving the brain to the edge.
Okay, let's unpack that. Edge AI. We hear it all the time in tech circles, but it feels like one of those buzzwords that gets slapped on everything.
Yeah.
What does it actually mean in practice?
The best analogy, and this comes straight from our source material, is to think about your own biology.
Okay.
Think about driving a car. Imagine you're driving down a suburban street, maybe a little too fast, and suddenly a ball rolls out in front of you.
Yeah.
What happens?
Instinct. Instinct takes over. I slam on the brakes
Yeah.
instantly.
Your eyes process the visual data, the ball. That signal goes to your brain identifies the threat, and it sends a signal to your foot to brake. It all happens locally, inside your body. That is edge AI.
Okay.
The processing happens at the source of the data.
Okay, that makes total sense.
Now imagine the cloud version of that same driving scenario. You see the ball. Your eyes take a high-resolution photo. They upload that photo via a 4G cellular signal to a server in a different state.
Oh.
A computer there analyzes the pixels, decides it's a ball, calculates the trajectory, and sends a signal back to your car to hit the brakes.
I would have hit the ball.
That's
and
rocket ball.
probably the kid chasing it. And I'd likely be in a ditch.
Exactly. That delay is latency. In a data center, latency is annoying because your video buffers.
Mm-hmm.
In a car or a tank or a medical device, latency is fatal.
So edge AI just means moving that processing power,
The brain.
the brain, right, directly onto the device itself. You process the data right there, eliminating the travel time.
You got it.
So that's the edge part. But then we have this other term, rugged AI. And I love the distinction the source makes here. If edge AI is the brain,
Rugged AI is the armor.
the armor.
That's the critical piece, because here's the problem. Standard computers are incredibly delicate. They're divas. They hate dust, they hate vibration, and they really, really hate heat.
So you take a standard high-performance server, you bolt it into a tank.
And it will fail in minutes.
So when we say rugged, what kind of specs are we talking about here? Is this just, a tough plastic case like I have on my phone?
No, this is military-grade survival. The source highlights two main enemies, shock and heat.
Let's start with shock.
Okay, shock. The requirement is often to survive 50G shocks.
50G. Can you contextualize that for me? What does 50G actually feel like?
To give you a reference, a serious car crash, the kind where airbags deploy and the frame is bent, that's usually around 30 to 40 Gs.
Wow.
So 50G is violent. It's the kind of force that would snap a normal motherboard in half. It would shatter the glass platters inside a traditional hard drive. It's the force of an explosion nearby, or a vehicle slamming into a ditch at high speed.
And the computer has to keep calculating during that shock.
Flawlessly. The AI cannot skip a frame or reboot just because you hit an IED. It has to maintain continuous operation.
Okay, that's incredible.
And then on top of that, physical violence, you have the temperature range. These systems have to operate from negative 40 degrees Celsius all the way up to 85 degrees Celsius.
Which is what, negative 40 to 185 degrees Fahrenheit?
It is basically an oven.
But wait, computers generate their own heat, right?
Yeah.
If I run a high-end game on my laptop, the thing gets hot.
That is the compounding problem. You are trying to run a supercomputer, which acts like a high-intensity space heater inside a sealed metal box, inside a desert, under the sun. It is a thermal nightmare.
So when this company, OSS, says they build AI transportables, they are just selling computers.
No.
They are selling the ability for a computer to exist where it fundamentally shouldn't.
Exactly. They are building mobile mini data centers that can do complex math while bouncing across a battlefield.
That is a great image. Mobile mini data centers surviving a war zone.
So we understand the what. Now let's talk about the who and the how. This company, OSS, has been around for a while, but you mentioned they look really different now in 2026. What happened?
They executed a strategic pivot that is just textbook burning the ships.
Burning the ships. That's a dramatic historical reference. Cortez, right? Landing in the New World and burning his boat so his men had no choice but to conquer or die.
A bit dramatic, but it fits the business strategy perfectly. See, for years, OSS was a bit of a jack of all trades.
Okay.
They did some of this high-end rugged stuff, sure, but they also owned a European subsidiary called Bressner Technology.
And what did Bressner do?
Bressner was a distributor. They basically resold other people's hardware. It was a steady business. It brought in reliable revenue every quarter,
Yeah.
but it was low margin.
How low are we talking?
Gross margins on that distribution business were around 24%.
Right.
In the hardware world, it's okay. It keeps the lights on.
But it's a volume game. It's a volume game. You're moving boxes. You aren't creating unique intellectual property.
And compared to the rugged defense stuff, what's the margin there?
That is where the gold is. The margins in their defense and military sector are around 45.6%.
That is a massive difference. Almost double the profitability per dollar of revenue.
Exactly. So the management team looked at this and said, why are we distracting ourselves with this low-margin resale business? We need to be a pure-play AI infrastructure company.
So they got rid of it.
They did. On December 30, 2025, so just a few weeks ago in our timeline, OSS closed the sale of Bressner.
For how much?
They sold it for $22.4 million.
So they sold the steady, boring part of the business, the safety net.
They sold the safety net to fund the war chest. That is why we call it burning the ships. They took that $22.4 million, added it to their balance sheet, and decided to go all in on the high-margin, proprietary, rugged AI tech.
And let's look at their bank account for a second, because this is rare for a micro-cap company. Usually when we talk about small tech companies, we're worried about them running out of cash.
That's the cash burn worry. Do they have enough runway? But OSS is in a unique position. As of early 2026, following the sale, they are sitting on roughly $39 million in net cash.
For a company of this market cap, That is a significant chunk of change.
And here is the kicker.
What's that?
Zero debt.
Zero debt.
Zero nothing. In a high interest rate environment, or even just a volatile market, having a fortress balance sheet like that gives them incredible optionality.
They don't have to be desperate.
They aren't desperate. They don't have to go begging to Wall Street if a contract gets delayed. They can invest in R&D, they can weather the storm, and they can execute this pivot without looking over their shoulder at the bank.
So they have the cash, they have the strategy. But let's play devil's advocate here. Strategy is easy to write on a PowerPoint. Execution is hard. And specifically, competition is hard.
Right.
What stops a massive defense contractor, a Raytheon, or a Lockheed Martin, or even a tech giant like Google from just doing this themselves? Why do they need this little company in California?
That brings us to the moat. And the moat here is built on two things: physics and red tape.
Let's start with the physics. We touched on the heat problem earlier, but I want to get deeper into this. Why is it so hard to cool a chip in a tank? Can't they just put a bigger fan on it?
If only it were that simple. Think about the environment. Dust, sand, maybe even chemical or biological agents in the air. Many military vehicles are sealed environments.
Hermetically sealed boxes.
Exactly. There is no airflow from the outside. If you suck in outside air to cool your computer, you are sucking in sand that will grind the fans to a halt, or conductive dust that will short out the motherboard.
So you can't use traditional air cooling.
You can't.
So how does OSS solve this?
Liquid cooling and advanced airflow ducting. This is their proprietary tech. They have designed systems that circulate fluid to pull heat away from the chips and radiator systems that can expel that heat even in an environment that's already hot.
But the real antagonist here is the chip itself.
It is. The AI chip.
The NVIDIA chip.
Specifically, the NVIDIA H100s and the new Blackwell architecture. These are the Ferraris of the computing world. But they consume massive amounts of power, 700 watts or more, just for the GPU. That creates a dense concentration of heat that is effectively a high-intensity space heater.
And chips have a safety mechanism, right? If they get too hot,
They throttle. Throttling means the chip intentionally slows down its processing speed to generate less heat. It's self-preservation.
like a runner slowing to a walk so they don't have a heart attack.
Perfect analogy.
Yeah.
But if I'm in a tank relying on AI to spot an incoming missile, I definitely do not want my computer to slow to a walk.
No, absolutely not.
Exactly. Throttling gets you killed. OSS's competitive advantage is that they guarantee these data center grade chips can run at full performance, no throttling, even when the environment is 120 degrees.
And that is a physics problem that's incredibly hard to solve.
It's the difference between building a race car for a track and building a rally car for the Dakar Rally. One is fast, the other is fast and indestructible.
Okay, so that's the physics moat. What about the red tape moat? Or, as the outline calls it, the certification barrier.
This is the reality of dealing with the Department of Defense. You cannot just move fast and break things.
No.
If you want to put a computer into a Bradley fighting vehicle or a Stryker, you have to pass MIL-STD certifications.
MIL-STD. It sounds official.
It stands for military standards. It involves years of testing, shock testing, vibration testing, electromagnetic interference testing, making sure the computer doesn't emit radio waves that mess with the tank's communications. It is a grueling, expensive, slow process.
Which sounds like a nightmare for a business trying to grow fast.
It is a nightmare to enter, but once you are in, it is a beautiful, high protective wall.
Okay.
OSS is already bolted into major fleets like the Bradley and the Stryker. Once the Army spends 3 years certifying your computer, they are not going to rip it out next year just because a competitor is 5% cheaper.
Because then they'd have to restart the entire 3 years of testing.
Exactly. The switching costs are astronomically high. It creates sticky revenue. Once you win the design, you tend to keep it for the life of the program, which can be decades.
So the slowness of the government actually works in their favor once they cross the finish line?
Precisely.
Okay, so they have the tech, they have the moat.
Yeah.
But investors want to see growth. They want to see wins. And sticky revenue can sometimes sound like stagnant revenue.
Mm-hmm.
But the source material highlights a very specific event that happened just recently on January 7, 2026.
Yeah.
This is the catalyst.
This was a pivotal moment. OSS announced a $1.2 million order. Now, I know what you're thinking.
Yeah,
In the world of government spending, $1.2 million sounds like a rounding error.
it does. We're used to hearing about billion-dollar contracts.
Mhm.
Why does this small order matter so much?
It matters for two reasons: the application and the customer.
Okay.
First, the application. The order was for a system providing 360-degree vision and sensor fusion for Army combat vehicles.
Let's break that down. Sensor fusion. That sounds like sci-fi.
It is the cutting edge of modern combat. Ideally, a combat vehicle has cameras, radar, and LiDAR looking in every direction. But that is way too much data for a human to process. The driver can't watch 12 screens at once.
Right, it's just information overload.
Sensor fusion is the AI taking all those different feeds, optical, heat, distance, and stitching them together into a single, understandable 3D model of the world.
So the soldiers inside can effectively see through the armor of the tank.
Exactly. It gives them situational awareness without having to pop their heads out of the hatch.
That sounds incredible, but it must take massive computing power.
It takes supercomputing power, and that's why this order is a validation. It proves OSS's tech can handle that heavy lifting in real time. But the second reason this order was special is the customer.
Who was it?
Well, the press release didn't name them, which is standard, but it described them as a new major U.S. defense prime.
The key word there is new.
New. It proves they aren't a one-trick pony. They aren't just relying on their legacy contracts with their old friends. They are winning new business with new prime contractors. The big guys like Lockheed, Raytheon, Northrop for next-generation platforms.
It validates that their tech is the standard for the future, not just a patch for the past.
You got it.
This brings us to a really important relationship that we need to clarify. We've mentioned NVIDIA a few times. We've talked about the H100 chips, the Blackwell architecture. I think a common cynical question would be, if NVIDIA is making the magic chip, won't they just dominate this whole market? Does OSS compete with NVIDIA?
That is the most common question, and the answer is a definitive no. OSS does not compete with NVIDIA. In fact, they are arguably one of NVIDIA's most important partners in this niche.
The source calls OSS a value-added wrapper.
That's a functional way to put it, but I like to think of it as the body. Think of NVIDIA as the brain. They make the silicon genius. But a brain cannot survive sitting on a table in the desert. It needs a skull. It needs a circulatory system. OSS builds the skull and the body that protects the NVIDIA brain.
And they aren't just buying these chips off the shelves like I would at Best Buy, right? They have a special status.
Yes, OSS is an elite partner with NVIDIA, a status they've held for over 14 years. This gives them Tier 2 OEM status.
And what does that mean practically?
Practically, that means OSS gets access to the roadmaps and the actual chips, like the new Blackwell architecture, before the general market.
So they get a head start.
A massive head start.
Yeah.
They can design their rugged systems alongside NVIDIA's release schedule. So when the chip comes out, OSS already has the armor ready to go.
They're enabling NVIDIA.
They are enabling NVIDIA to go places NVIDIA couldn't go on its own. NVIDIA dominates the data center. OSS takes NVIDIA to the mud.
Exactly. And importantly, while they are close partners, OSS is chip agnostic.
Meaning they aren't married to NVIDIA?
Meaning they date others. They work with Intel, they work with AMD, they work with Western Digital.
Yeah.
If a customer says, we have a legacy software stack that runs better on Intel, OSS can swap the brain, but keep the armor.
So they're selling the infrastructure.
Not just the silicon.
Right.
We've talked a lot about tanks and war zones, and obviously that's the sexy high-stakes part of the story. But the source material points out that the total addressable market, the TAM, is much bigger than just defense.
Oh, much bigger.
We're talking about a market projected to grow from roughly $25 billion in 2025 to somewhere between $118 billion and $144 billion by 2033. Where is that growth coming from outside of the military?
It's coming from the industrialization of AI, basically anywhere that is dirty, moving, or dangerous.
Like the medical field.
Let's look at the medical field. It seems counterintuitive, right?
Yeah.
Hospitals are usually clean, quiet, and air-conditioned. Why do they need rugged AI?
Yeah, that was my question.
Think about the machines themselves. OSS has a $25 million 5-year program for liquid-cooled breast scanning devices.
Yeah.
These are incredibly high-precision machines. They generate massive amounts of high-fidelity image data. You can't upload gigabytes of private patient data to the cloud for processing while the patient is waiting on the table.
Takes too long. And it's a privacy risk.
Exactly. You need to process it right there next to the patient. That's edge AI again. But doing that requires a powerful computer which generates heat. And you cannot have a computer with screaming fans in a patient examination room.
No, it creates anxiety. It's loud.
Right. OSS's liquid cooling tech allows them to build a powerful computer that is virtually silent.
That makes perfect sense. High performance, tight space, need for silence. What else?
Autonomous trucking. This is the dream of self-driving logistics.
We've been hearing about this for years.
We have, and OSS has partnerships with companies like Embark. But here's the problem they solve: the dead zone. Think about a long-haul truck driving across the country. It's cruising through rural Nevada. Suddenly, the cell service drops.
No 5G, no cloud.
Zero. But the truck is moving at 65 miles per hour. It cannot stop driving just because it lost the internet. It needs a supercomputer on board to read the road, detect obstacles, and drive the truck.
And that computer has to survive hundreds of thousands of miles of constant vibration.
Exactly. Highways aren't smooth glass. The constant vibration would rattle a normal server to pieces in a week. OSS builds the ruggedized brain that sits in the cab.
And I see here they are also in the marine sector.
Autonomous shipping. They're partnering with NVIDIA to guide ships in busy shipping lanes. It's like air traffic control, but handled by AI on the ship itself to avoid collisions, and also on oil rigs, using AI for predictive maintenance.
Explain that one.
Basically, the AI listens to the machinery. It analyzes the vibration and sound of a drill or a pump. It can predict that a bearing is going to fail in 48 hours, long before a human would notice.
And that saves millions in downtime.
Millions. But again, an oil rig is a hostile environment. Salt spray, storms, heat. You need rugged AI to survive there.
So the thesis really is, as the world becomes more automated, the computing power has to move out of the air-conditioned server room and into the real world.
Right.
And the real world is a rough place.
Correct. OSS is the company building the bridge between those two worlds.
Okay, let's put our investor hats on for a minute. We've painted a very rosy picture here.
Yeah.
Cool tech, big moat, growing market, fortress balance sheet.
Right.
But every investment has risks. The source calls this the investor's analysis. What are the red flags? What is the bear case here?
There are three main risks that any potential investor needs to weigh carefully. The first is lumpiness.
Lumpiness, not a technical term, but very descriptive.
Very. Defense contracting is a marathon, not a sprint. You might work on a deal for 2 years doing demos and tests and get paid almost nothing. Then suddenly you get a $10 million order in 1 quarter.
And then maybe nothing for the next 2 quarters.
Exactly. Revenue can be very choppy. It's hard to predict quarter-over-quarter growth in a straight line. If you are an investor who panics when a quarterly report is flat, this might drive you crazy.
So patience is required. You have to look at the backlog.
You have to look at the backlog and the trailing 12 months. The second risk is execution risk. We talked about their pipeline. The source mentions a sales pipeline of over $1 billion.
But a pipeline isn't a bank account.
Correct. A pipeline is potential business. It's conversations, proposals, maybe some early designs. It is not signed contracts.
The risk is conversion.
The risk is conversion. Can they convert that $1 billion of interest into actual revenue? And more importantly, can they do it profitably? Especially now that they've sold the steady cash flow of Bressner.
Right, they burn the ship.
They burned the ships. They are betting everything on their ability to execute on these complex engineering projects. The market is watching to see if they can turn that pipeline into consistent GAAP profitability in 2026.
And the third risk?
Concentration. Specifically, the NVIDIA concentration. Even though they work with others, let's be honest, the AI boom is an NVIDIA boom. OSS is heavily tied to the NVIDIA roadmap.
If NVIDIA sneezes, OSS catches a cold.
Precisely. If NVIDIA suddenly decides to change their architecture in a way that makes ruggedization harder, or if they change their partner program, OSS is vulnerable.
Or, worst case?
Or in a worst-case scenario, if NVIDIA decides to build their own rugged systems.
That likely.
It's unlikely. The rugged market is high margin, but it's low volume compared to what NVIDIA does. NVIDIA sells millions of chips to data centers. They probably don't want to deal with the headache of MIL-STD certification for a few thousand tanks.
But the risk is non-zero.
The risk is non-zero. OSS is a small fish swimming next to a whale. You have to be careful not to get swamped by the wake.
So let's try to summarize this narrative for the listener. We have a company that has transformed from a general hardware distributor into a specialized master of the rugged edge.
Yes. They saw the future coming. They saw that AI was going to move out of the data center and into the physical world, and they realized that the physical world is harsh.
They burned the ships, sold the safety net, and are now sitting on a pile of cash with a clear mission to build the hardware that keeps the software alive.
That's the core of it. We are seeing a shift in warfare and industry toward autonomy. Drones, robot dogs, unmanned ships, automated factories, all of these things need brains.
And those brains need bodies that can survive.
OSS builds the bodies.
It brings us to the so what for our listener. Why should they care about a small microcap in California?
Because it represents a fundamental shift in how we think about technology. For the last decade, tech has been about software. It's been about apps and SaaS and the cloud. Software eats the world, as the saying goes.
But software is abstract.
Exactly. Now, we're entering a phase where software has to live in the world. The next big investment opportunity might not be the code itself, but the infrastructure that allows that code to exist where it matters most, on the edge, in the heat, in the dirt.
It's a final, provocative thought. We often think of AI as code floating in the ether. But this deep dive reminds us that AI is physical.
It is.
It generates heat, it takes up space, and it breaks when you drop it.
Physics always wins in the end. And the companies that respect physics are the ones that will win the contract.
Physics always wins. I think that is a perfect place to leave it.
Yeah.
A huge thank you for walking us through the thermodynamics and the financials today.
My pleasure.
And thank you to you, the listener, for diving deep with us. We hope this gave you a new perspective on the metal and silicon powering the AI revolution. Whether you're on a treadmill, in a car, or maybe even in a rugged environment yourself, we appreciate you tuning in.
Stay curious.
We'll see you on the next Deep Dive.